Welcome back, everybody. Today we're going deep into AI,
Oh, yeah.
specifically
Love it.
two concepts
Yeah.
shaping the future of these intelligent machines:
Right.
theory of mind and meta-reasoning.
I mean, this is like getting a sneak peek into the future, how these AI might think and
Yeah.
interact with the world.
Exactly.
Maybe even like understand us humans like on a deeper level.
Totally. And our source material for this deep dive is this fascinating report from the DVCOM Army Research Laboratory.
Okay.
It's called
Catchy title.
Theory of Mind and Meta-Reasoning for Artificial Intelligence.
Right.
Now, I know what you're thinking.
What I'm thinking.
Academic report.
Yeah.
Sounds a little dry.
A little bit, right.
But trust me,
Okay.
this stuff is mind-blowing.
Yeah.
We're going to break it down into something you can actually wrap your head around.
That's what we do best.
That's what we do.
right here. So,
What I think is so compelling about this report
yeah,
is it doesn't just define these concepts.
it actually explores their real world implications,
Yeah.
like how they could revolutionize the way AI interacts with us in the future.
I love it. Okay, so
Yeah.
let's start with theory of mind, or TOM for short.
Yeah.
It's all about understanding what's going on in someone else's head,
Right.
their beliefs, their intentions,
Yeah.
even if they're totally wrong.
Exactly. It's
Yeah.
like having that sixth sense
Okay.
that tells you your friend is upset,
Right.
even if they're putting on a brave face.
I gotcha.
Yeah.
So that makes sense.
Mm-hmm.
But how do researchers actually study this in humans?
Well, one classic experiment
Yeah.
is the Sally Ann test.
Okay, I've heard of this.
Okay.
Yeah.
So imagine two dolls,
Oh, like,
Sally and Ann.
got it.
Sally puts her marble in a basket
Okay.
and leaves the room.
Right.
Sneaky Ann moves the marble to a box.
Sneaky Sagik.
When Sally comes back,
Okay.
researchers ask a child, where will Sally look for her marble?
Oh, that's
So the kid has to understand
Mhm.
that Sally has a false belief
right.
that she'll look in the basket,
Right.
even though the marble's not there anymore.
It's not there.
Yeah, it's pretty clever.
That is clever.
It helps researchers understand how children develop this ability to
Yeah.
think about other people's thoughts.
That's fascinating.
What's interesting
Yeah.
is that while young kids often don't pass this test,
Really?
other research suggests that Tom might actually develop much earlier
Oh, wow.
than we initially thought. We just needed like different ways to test it.
So even though we developed Tom,
Mm.
does that mean we use it all the time, even as adults?
You know what I mean?
I mean,
That's interesting.
I know I've definitely made assumptions about what people are thinking
Right.
without really knowing for
Yeah,
sure.
you bring up a great point.
Right.
The report actually mentions a study where people received instructions from an instructor who was clearly clueless, but instead of questioning them, the participants just went along with it.
Really?
So it seems like our brains sometimes take shortcuts,
Wow.
and we don't always stop to fully consider someone else's perspective.
That is fascinating.
Yeah.
Isn't it fascinating, though, how researchers are trying to teach AI to do something that even humans struggle with
Totally.
sometimes?
Absolutely. To understand how humans use Tom, they're developing computational models,
Okay.
like Bayesian models
Right.
and inverse reinforcement learning.
Okay. Those sound a bit intimidating.
It sounds a little complex.
Can you break those down a bit?
Think of it like this. The model uses a bit of probability and guesswork,
Okay.
just like we do,
Right.
to figure out what someone is thinking
Mhm.
or what their goals are based on their actions.
Right.
The report talks about a study
Yeah.
where they used one of these models to predict people's choices at food trucks.
Okay. So the model was trying to figure out,
Right.
okay, this person's in the mood for a burger, so they'll probably go to that food truck.
Exactly. And what's amazing is
Yeah.
that the model actually did a pretty good job of predicting people's decisions, even when the customer's preferences changed.
Oh, wow. So it's
Uh-huh.
like the model was learning to think like a human, figuring out what motivates people's choices.
Precisely. And just like humans,
Yeah.
these models use previous knowledge
Right.
or assumptions, what we call priors,
Okay.
to make sense of the world by studying these models.
Yeah.
We might even gain insights into cognitive differences in humans, like how people with schizophrenia or autism
Oh, wow.
might use Tom differently.
That's incredible.
Yeah.
It seems like Tom is a pretty complex thing to model,
It is.
even for humans.
Yeah.
So how are researchers applying this to AI?
It's still early days, but researchers are making some fascinating progress. They've developed AI agents
Yeah.
that can actually recognize different species of other agents
Okay.
based solely on their behavior.
Species of agents. What does that even mean?
Imagine a group of robots. Some are programmed to be helpful,
Right.
others are more competitive.
Okay.
These AI agents were able to figure out which robot was which just by observing their actions,
Wow.
even in situations where the robots had limited vision.
So they were basically developing their own little robot society
China.
with different personalities and
Right.
ways of interacting.
Exactly.
That's wild.
They even conducted a version of the Sally Ann test
Really?
with these AI agents.
That's AI agents.
Yeah.
Wow.
And some of them showed signs of understanding false beliefs,
Okay, hold on.
just like in the experiment with children.
AI understanding that someone can have a belief.
Yeah.
That's totally wrong.
It could be.
That's starting to sound a little too human-like for comfort.
It is a fascinating area of research, especially when you consider the implications for human-robot collaboration.
Right.
Imagine a robot working alongside a construction worker,
Okay.
understanding their nonverbal cues
Yeah.
and anticipating their needs. It could lead to safer, more efficient work environments.
Now, that's what I call a game changer.
Right.
But if AI is going to be working so closely with humans,
Yeah.
doesn't there need to be a way to make sure it's acting responsibly?
You're hitting on a crucial point.
Right.
As AI becomes more sophisticated, we need ways to ensure it's aligned with our values and goals.
So it's not enough for AI to just understand our thoughts and feelings.
Not enough, no.
It also needs some kind of control system,
Right.
a way to manage its own thinking.
Precisely. And that's where meta-reasoning comes in.
Okay.
It's essentially thinking about thinking, a higher level process
Yeah.
that monitors and controls how the AI makes decisions.
So is meta-reasoning like the AI equivalent
Okay.
of having a conscience?
I like that that's an interesting way to think about it, to understand meta-reasoning.
Okay.
It's helpful to see it as distinct from theory of mind.
Okay.
Theory of mind is all about other minds,
Got it.
whereas meta-reasoning is about your own thinking process.
Okay.
But here's the key.
Uh-huh.
Theory of mind can be a type of meta-reasoning,
Okay.
a specific tool within a larger framework.
Okay, my mind is officially blown,
It's a lot.
but I'm hooked. Let's break down this whole meta-reasoning thing. How does it actually work?
Okay, so imagine a simple alarm system.
Okay, I can do that.
At the most basic level, you have sensors detecting motion. That's the ground level.
Gotcha.
Then you have the alarms algorithm deciding whether to sound the alarm based on the sensor data. That's the object level.
Okay.
So if someone breaks in, the alarm goes off.
Right, got it. But where does meta-reasoning come in?
Now imagine the alarm keeps going off because a tree branch is brushing against the sensor. Annoying, right?
Yeah, so annoying.
That's where meta-reasoning steps in. It analyzes the situation, the frequent false alarms,
Okay.
and decides to adjust the sensitivity of the alarm, perhaps requiring more motion events before triggering it.
So it's like the alarm system is learning from its mistakes and becoming smarter over time.
You got it.
That's cool.
Meta-reasoning is all about monitoring and controlling that object level of thinking to make better decisions.
I like it.
And just like theory of mind,
Yeah.
it has huge implications for the future of AI.
Okay, now this is where it gets really interesting.
It does.
So is meta-reasoning like the AI equivalent of having a conscience?
That's an interesting way to think about it, to understand meta-reasoning. It's helpful to see it as distinct from theory of mind. Tom is all about other minds, whereas meta-reasoning is about your own thinking process. But here's the key. Tom can be a type of meta-reasoning, a specific tool within a larger framework.
Okay, my mind is officially blown, but I'm hooked.
Hmm.
Let's break down this whole meta-reasoning thing. How does it actually work?
Okay, so imagine a simple alarm system at the most basic level. You have sensors detecting motion, that's the ground level. Then you have the alarms algorithm deciding whether to sound the alarm based on the sensor data, that's the object level.
Okay, I can do that. So if someone breaks in, the alarm goes off.
Yeah.
Got it. But where does meta-reasoning come in?
Now imagine the alarm keeps going off because a tree branch is brushing against the sensor. Annoying, right? That's where meta-reasoning steps in. It analyzes the situation, the frequent false alarms, and decides to adjust the sensitivity of the alarm, perhaps requiring more motion events before triggering it.
Yeah. So annoying. So it's like the alarm system is learning from its mistakes and becoming smarter over time.
You got it. Meta-reasoning is all about monitoring and controlling that object level of thinking to make better decisions. And just like theory of mind, it has huge implications for the future of AI.
I like it. Okay, now, this is where it gets really interesting, right? My brain needs a moment to process all of this. We've covered a lot of ground already.
We have, but we're just getting started. There's so much more to explore about meta-reasoning and its applications in AI, especially when it comes to multi-agent systems where multiple AI agents are working together. That's where things get really interesting.
Okay, I'm all ears. Tell me more about these multi-agent systems. What are some real-world examples where meta-reasoning is already being used, and what are the potential benefits and challenges of having multiple AI agents working together?
Yeah.
Multi-agent systems. Okay, I'm picturing like a team of robots building a car, or maybe even a whole city. Is that kind of what we're
Yeah,
talking about?
it could be something like think about like a fleet of self-driving cars.
Okay.
Navigating through rush hour traffic, each car is like an intelligent agent,
Right.
making decisions about its speed, its route, and how to avoid collisions. Or imagine a team of robots
Okay.
working in a disaster zone, searching for survivors,
Yeah.
and coordinating their efforts to like provide aid that's the power of multi-agent systems, or MSS.
So instead of one super intelligent AI, it's more about teamwork and collaboration between a bunch of smaller AI agents.
Exactly. And that's where meta-reasoning comes in. Remember, it's all about thinking about thinking. In multi-agent systems, meta-reasoning helps these individual agents coordinate their actions, manage resources efficiently,
Yeah.
and even learn from each other's experiences.
So it's like having a built-in coach
Yeah.
or a team captain
Right.
that helps the AI agents work together seamlessly,
Yeah.
even in like complex and unpredictable environments.
That's a great analogy. The report dives into some interesting examples
Okay.
of how meta-reasoning can be implemented in these systems.
Yeah.
For instance, it can control communication frequency between agents.
Okay.
If each agent is constantly broadcasting like every little detail,
Right.
it can lead to information overload and slow down the entire system.
Like having too many people trying to talk at once in a meeting, nobody gets anything done.
Exactly. Meta-reasoning can help the agents determine when it's like necessary to communicate
Right.
and when it's better to stay focused on their individual tasks, only sharing information when absolutely necessary.
So it's all about striking that balance between collaboration and individual initiative. What are some other ways meta-reasoning can be used in these systems?
Another interesting example is task allocation. Imagine you have a team of robots.
Okay.
Working in a warehouse fulfilling orders, meta-reasoning can help determine which robot is best suited to handle a particular task based on their capabilities, their location in the warehouse,
Yeah.
and even their current workload.
It's like having a project manager built right into the system, making sure every task is assigned to the right robot at the right time.
Precisely. And the report highlights that meta-reasoning can be implemented in different ways.
Okay.
From having each agent make independent decisions to having a more centralized control system that oversees the entire team.
I can see how having a centralized control system could be more efficient in some situations.
Yeah.
But wouldn't that also create a single point of failure? What if the central controller malfunctions?
That's a great question, and it points to some of the challenges researchers are still working through. It's all about finding the right balance between control and flexibility, depending on the specific application.
So it's a bit like deciding between having a strong leader versus empowering individual team members to make their own decisions.
Right.
It's all about context and choosing the right approach for the job. What about learning? Can these multi-agent systems actually learn from their experiences and improve over time?
Absolutely. And that brings us to another interesting aspect of meta-reasoning, the trade-offs between online and offline learning. Online learning means the system is constantly adapting and adjusting its strategies based on new experiences and feedback, sort of like learning on the fly. Offline learning relies more on pre-programmed rules and knowledge that doesn't change as the system operates.
So online learning is more flexible and adaptable, but probably requires more computational power and might be slower to react in real time. Offline learning is more efficient, but might not be as effective in dynamic environments where things are constantly changing.
You hit the nail on the head. The choice often depends on the specific application and the resources available. Think about a self-driving car in a controlled environment like a highway. Offline learning might be sufficient, but in a bustling city with pedestrians, cyclists, and unexpected obstacles, online learning becomes crucial.
So the difference between studying for a test from a textbook versus learning through real-world experience. Sometimes you need both. Okay, I'm starting to see how all of this ties together. We have theory of mind, which helps AI understand the intentions and beliefs of others. Then we have meta-reasoning, which helps AI manage its own thinking process, make better decisions, and even learn from its experiences. And when you combine those things in multi-agent systems, you get this incredible potential for collaboration and intelligent problem solving.
Exactly. And it's this interplay between theory of mind and meta reasoning that's really pushing the boundaries of what AI can achieve.
Earlier we talked about how Tom can sometimes be a type of meta reasoning.
Right.
I'm still a little fuzzy on how those two concepts relate to each other. Could you clarify that for me?
Of course, remember the alarm system example, meta reasoning, is all about monitoring and controlling that object level of thinking the alarm's decision-making process. Based on the sensor data, it's the alarm system looking inward at its own operations.
Right, and then it adjusts its own sensitivity to avoid false alarms.
Exactly. Theory of mind, on the other hand, is more outward focused.
Okay.
It's about making inferences about the mental states of other agents
Right.
based on their actions and behaviors.
So if we go back to the warehouse robots, Tom would be like one robot trying to understand why another robot chose to pick up a specific package,
Yeah,
even if it doesn't have access to that other robot's internal decision-making process.
that's a great way to put it. It's about recognizing that other agents have their own beliefs, goals, and intentions that might be different from our own.
And that's crucial for effective collaboration, whether it's between robots, between humans, or between humans and robots. We need to be able to understand each other's perspectives, even if we don't always agree.
Precisely. And as AI systems become more integrated into our lives, that ability to understand human intentions and anticipate our needs will be paramount.
Okay, so we've covered theory of mind, meta-reasoning, and how these concepts are shaping the future of multi-agent systems. But what about the big picture? What does the report say about the future of Tom and meta-reasoning in AI development overall?
Well, it suggests that while meta-reasoning is already a well-established area of research in AI theory of mind, is still relatively unexplored, especially when it comes to practical applications.
Why do you think that is? Is it just because Tom is so complex and difficult to model?
That's definitely part of it. Remember, Tom is closely tied to human cognition, and we're still unraveling the mysteries of how our own minds work, plus replicating those capabilities in machines is no easy feat. But there's another interesting angle that the report highlights.
I'm all ears. Tell me more.
It seems that some of the earlier attempts to model Tom and AI were perhaps a bit too ambitious. They tried to create highly detailed and complex models that ended up being too computationally expensive or too difficult to implement in real-world systems.
So it's like trying to build a skyscraper before you've even mastered the basics of laying bricks.
That's a great analogy, but the good news is that more recent approaches to computational Tom are taking a different tack. They're using simpler, more heuristic definitions of Tom that focus on specific aspects of social cognition.
Heuristic, can you explain what that means?
A heuristic is like a mental shortcut, a rule of thumb that helps us make quick decisions without having to analyze every possible option.
So instead of trying to model every single nuance of human Tom, they're focusing on the key elements that are most relevant for AI applications.
Exactly. And this shift towards simpler, more pragmatic approaches to computational Tom seems to be yielding promising results.
That's encouraging to hear. It sounds like there's still a lot of potential waiting to be unlocked. So where do we go from here? What are the next big challenges and opportunities for researchers in this field?
That's a great question, and I think it leads us perfectly into the final part of our deep dive. We've talked about the what and the how of Tom and meta-reasoning. Now it's time to explore the why, the bigger implications of these technologies for the future of AI and its impact on our lives.
Okay, I'm ready to tackle the big questions.
Yeah.
Let's dive in. Okay, so we've been talking about all the nuts and bolts, theory of mind and meta-reasoning.
Right.
But I think what's really on everyone's mind is, what does all this mean for us?
Right.
How will these advancements in AI actually impact our lives?
That's the million-dollar question, isn't it?
It is.
And I think the report does a good job of highlighting both the exciting possibilities and the potential challenges that lie ahead.
I am ready for some serious future casting.
All right.
What kind of changes are we talking about here?
Well, think about how we interact with technology today. We rely on computers, smartphones,
Right.
and countless other devices to do our jobs, connect with loved ones, and navigate the world around us. But imagine a future where those interactions become even more seamless
Yeah.
and intuitive.
So instead of just telling my call mom, I could just think it and it would happen.
Yeah.
Is that the level of integration we're talking about?
It could be something like that. Imagine AI assistants
Okay.
that truly understand your needs and preferences, even anticipate them before you even realize them yourself.
Oh, wow.
They can help you manage your schedule, filter out information overload,
Okay.
and even provide personalized recommendations tailored to your unique personality and goals.
All right, that sounds pretty amazing.
Right.
But what about the darker side of all this? What
Yeah.
about the potential for misuse or unintended consequences?
You're right to raise those concerns. Whenever you have powerful new technologies, there's always the risk of them being used in ways that weren't intended or even foreseen.
I'm thinking about things like privacy security,
Right.
and even the potential for AI to be used for manipulation or control. Are these concerns addressed in the report?
While the report doesn't delve too deeply into specific ethical concerns,
Okay.
it does emphasize the importance of transparency and explainability in AI development.
Right.
If we're going to create AI systems that are capable of making decisions that impact our lives, we need to be able to understand how those decisions are being made.
Right. It's not enough for the AI to just be smart. It needs to be able to communicate its reasoning to us
Yes.
in a way that we can understand and trust.
Exactly. And it's not just about understanding the how, but also about ensuring that the AI's goals are aligned with our own. We need to be very thoughtful about how we design these systems and what values we instill in them.
So transparency, explainability, and values alignment seem like crucial factors in shaping the future of AI.
Right.
But I have to admit, all of this talk about AI understanding our intentions and motivations is making me wonder, will there ever be a point where we can't tell the difference between human intelligence and artificial intelligence?
That's a question that has fascinated philosophers and scientists for centuries. And while we're still a long way from creating AI that truly rivals human consciousness, the advancements in areas like theory of mind and meta-reasoning are certainly blurring the lines.
It's like we're on the cusp of something truly revolutionary, but we're not quite sure what that something is yet.
I would think that's a great way to put it. We're entering uncharted territory, and it's both exhilarating and a bit unsettling.
As we've been talking, I've been trying to apply these concepts to my own life. Like, am I really using my theory of mind effectively
Hmm.
in my interactions with others? Am I thinking about my own thinking process in a way that helps me make better decisions?
That's a wonderful insight, and I think it speaks to one of the most important takeaways from this whole conversation. Studying AI isn't just about understanding machines, it's also about understanding ourselves.
Right. It's like holding up a mirror to our own cognitive processes and questioning our assumptions about how we think and learn.
Exactly, and that self-reflection can be incredibly valuable. It helps us to be more mindful of our own biases, more empathetic towards others, and more intentional in our actions.
Okay, so we've reached the end of our deep dive
We have.
into theory of mind and meta-reasoning. I have to say, this has been one of the most mind-bending episodes we've done yet.
I agree. It's been a fascinating journey exploring the cutting edge of AI research, and while we may not have all the answers, I think we've raised some important questions that will continue to shape the conversation about AI for years to come.
Exactly. And ultimately, that's what the deep dive is all about, provoking thoughtful discussion and inspiring our listeners to engage with these complex topics.
Well said so. Until next time, stay curious and keep exploring the world around you.
And don't forget to think about your thinking.
That's great advice. Until our next deep dive, everyone.